Now, a lot of people get all worked up about trying to convert units in the metric system, which to me doesn't make much sense because one of the main points of the metric system is to make it where converting is so easy you don't even have to think about it. It's all base 10, and it uses prefixes just to tell you how many times to jump the decimal or what scientific notation to use. Now, you have used plenty of scientific notation in the past. We're just going to jump in to using it right here. Let's look at the prefixes. Mega means times 10 to the 6th, or a million. Kilo means times 10 to the 3rd, or 1,000. Hecto and deca, I'm just listing there. Those aren't common prefixes that are used, and then you would have your base unit. Deci, also not a common, times 10 to the negative 1, jumping the decimal the other way. Centi, a very common one, times 10 to the negative 2nd, like centimeters. Millimeters, right, times 10 to the negative 3rd. And whenever we start getting down onto the atomic, and then the atomic level, a little bit bigger than atomic, micro times 10 to the negative 6, and then down into the atomic land, nano times 10 to the negative 9th, whenever we start getting into the nuclear options at the very end of the course. Now, these prefixes are all ones that we will actually give you on the equation sheet. In fact, we're going to keep ourselves, at least for now, limited to just kilo, centi, and milli. Notice that I didn't give the things between mega and kilo, between milli and micro, and between micro and nano, because they're really not used that much. In fact, most of the times we keep ourselves in a group of threes, into jumping powers by 3 times. -9, -6, -3, base unit, 3, 6, so forth and so on. Centi and milli are kind of the exception. We like the centi part also, oftentimes 10 to the negative 2. Let's look at how easy it is to do these conversions. Now, we are always going to be converting back to base units. If you convert all measurements back to base units, really you don't have to worry about anything. So when in doubt, convert to base units. You're going to hear that out of my mouth a lot this year. When in doubt, convert back to base units. And when you do that, you can just simply use just what the prefixes mean here in scientific notation. So check it out. I have down here at the very bottom 5.2 kilometers, and I want to convert it to the base unit of meters. Kilometers. Prefixes always have a letter out in front. So 5.2 kilometers, how many meters is that? Not a big deal. 5.2 kilometers, I'm just going to simply write 5.2, and then I'm going to change the kilometer into what it means, times 10 to the 3rd, because that's the entire point of the kilometer. The kilometer means times 10 to the 3rd. So I literally swap the K for what it means. Let's look at another one. 32 millimeters. Convert that into meters. Now, a millimeter is very small. We're trying to convert that into meters here, but really it's not a big deal. I just simply write down my 32 and then times 10 to the negative 3rd. You say, where did that times 10 to the negative 3rd come from? Well, here's my prefix, milli, base unit meters. What does milli mean? Milli literally means times 10 to the negative 3rd. Since milli means times 10 to the negative 3rd, I just put it in there. Now, the perceptive amongst you might point out, hey, this is incorrect scientific notation down here. That should be reported to be 3.2 times 10 to the negative 2nd. Why, yes, that would be correct scientific notation. But here's the thing. You're not just going to convert and let it be. You're about to use it mathematically. And whenever you start using it mathematically, your calculator doesn't care that it's incorrect scientific notation. You can put in 3.2 times 10 to the negative 3rd into your calculator and do math with it, and it turns out just fine. The calculator always gives you the answer in correct scientific notation as well. All right, let's actually apply this maybe in a couple of problems. Number one, calculate, and we're going to need to get the answer in meters per second, the average velocity, v equals question mark, of a slug that travels 52 centimeters. That's a displacement in 1.5 minutes. That is a time. So I write my variable bank, and here's where I stop. Before I go on to the next step, I'll go ahead and write down what we were doing last time. Next step is to write the equation that we're about to use. But before I do that, let's convert everything back to base units. The displacement should be in meters, and the time should be in seconds, right? And this is right now in minutes. Now, 52 centimeters, convert that. That just simply becomes 52 times 10 to the negative 2nd meters. 0.52 meters might be the way you would like to think about it if you were converting the same way in middle school, jump twice to the left. But see how easy it is if you just simply take the prefix centi and then write what it means? Now, minutes to seconds requires a little bit more work, but this is common math that you did back in elementary school for that matter. To get from minutes to seconds, I just need to multiply by 60. So I come out with 90 seconds here. Now I have everything in base units so that I can substitute into my equation. And whenever I type into my calculator using scientific notation, 52 times 10 to the negative second, divided by 90 here, I turn out with 0.0057 repeating, and so round that to 0.0058 meters per second. All right, number 2, calculate how long. That means, like we talked about in our previous video, we're solving for time. How long it will take a plane traveling 0.31 kilometers per second. Hold on. That is a displacement, kilometers, divided by a time, seconds. This is a velocity here. To go 850 meters. That is a displacement. So let's make our variable bank. Now, one of the reasons that I am always going to encourage you to make a variable bank is it lets you look at the units, and we can see here the units don't match. Notice in the velocity it's kilometers, and in the displacement it's meters. They don't match up. We need to convert the velocity back to base units, back to meters per second. When in doubt, convert back to base units. Now, the denominator, seconds, is right. It's the numerator, kilometers, that's not right. I need to get it into meters. Not a big deal. How do we go from kilometers to meters? Well, kilometers simply means times 10 to the third. So I have 0.31 times 10 to the third meters per second. Now I'm ready to substitute into my equation and solve. And in the end, I end up with 2.7 seconds. Long story short here, do not be afraid of scientific notation. Do not be afraid of converting metrics. Whenever you embrace using scientific notation, just swap the prefix for what the prefix means, knowing that even if you're scared somewhat of scientific notation, your calculator isn't. It takes on scientific notation without any problem. You can type in 0.31 times 10 to the third into your calculator. Not a big deal. You can do 850 divided by this in your calculator, and it'll work it out for you, even if you're worried about scientific notation. So don't be afraid of converting metrics. Use the prefixes and what they mean.